Section 12.5 is the binomial theorem. So here we have 4 binomials raised to a power. So go ahead and pause the video and expand or FOIL out these binomials. So for the first one, x plus a to the first power is just x plus a. X plus a quantity squared is the same thing as x plus a times x plus a. So that's x squared plus 2ax plus a squared. X plus a quantity cubed is x plus a times x plus a times x plus a, which is x cubed plus 3ax squared plus 3a squared x plus a cubed. This one, we don't know what n is, so there's no way at this point to actually multiply this out. It would be x plus a times itself n times. So in this section, we're going to talk about, this is not too bad to do by hand by just straight foiling, but if n was 10 or 40, you're not going to want to FOIL this out that many times. So the binomial theorem is a shortcut to expand binomials raised to a power. For the binomial theorem, we need to use n choose r. N choose r is saying that I have n possibilities and I want to choose r of them. How many different possibilities can I have? So the mathematical definition for n choose r is n factorial divided by r factorial times n minus r factorial. Factorial means you take every value starting at n and multiply n times n minus 1 times n minus 2 all the way down times 3 times 2 times 1. So multiply every number from 1 up through n. The 0 factorial is defined as 1. Your graphing calculator and your scientific calculator have an n choose r button. So over here I have the directions for both of those. You type in the first number and then you have to get to probability, which for graphing calculator is math and then probability. And then number 3 is n choose r. For the scientific, you scroll over to n choose r and then type in the second number, and that will give you what the n choose r is. So if I want to do the first one, 0 choose 0, I have 0 possibilities and I want to pick 0 of them. How many different ways can that happen? So I end up with 0 factorial divided by 0 factorial times 0 minus 0 factorial. So again, 0 factorial is defined as 1, so I have 1 divided by 1 times 1, so all of this is just 1. For the next one, if we want 3 choose 2, we're going to have 3 factorial divided by 2 factorial times 3 minus 2 factorial. So 3 factorial is 3 times 2 times 1, 2 factorial is 2 times 1, 1 factorial is just 1. So on these, a lot of things are going to cancel. So the 2 times 1 is both in the numerator and the denominator, so those both cancel, and we're just left with 3 divided by 1. So 3 to choose 2 is just 3. So go ahead and pause the video and do 4 choose 3, either using your calculator or by just setting up the factorials. So on this one, you have 4 factorial divided by 3 factorial times 4 minus 3 factorial. So 4 factorial is 4 times 3 times 2 times 1. 3 factorial is 3 times 2 times 1. 1 factorial is just 1. So the 3 times 2 times 1 cancel. You end up with 4 divided by 1, or just 4. A couple ones to just know off the top of your head. Anything choose 0. There's only one way you can have a certain number of things and choose 0 of them. So that's just 1. And then n choose n, so any number choose itself. There's only one way you can pick all of the things in the set, so that's also 1. N choose it 1, so anything choose 1 is just itself n. There's only n ways you could do that. And then same with n choose n minus 1. That's just going to be n. So those are a couple to know off the top of your head. This is called Pascal's triangle. It's a shortcut to expanding binomials. Basically, this would be at the coefficients of x plus a to the 0 power. This would be the coefficients of x plus a to the first power, and so on and so forth. There's a pattern to it. The 2 above it always add up. It's 1 down the diagonals, and then the 2 above it add up to the 1 below it. This is not something you have to have memorized, but this is another way to expand binomials. Here's the definition for binomial theorem to expand binomials of the form x plus a to the nth power. So the way it works is your power of x, or whatever this first term is, the whole term here, starts at the same power as the exponent in the problem, and the second term starts at 0. And then as you go down, the power of the first term goes down by 1 every single time until it gets to 0. And the power of the second term goes up by 1 every single time until you get to n. the coefficients, or the number in front that these are going to be multiplied by, start at whatever n is, choose 0, so 1, and then in choose 1, in choose 2, and choose 3, all the way up until you have in choose n. So if I set up the full expansion of 2y minus 3 to the 4th power, it's going to start with 4 is n, so it's going to start with 4, choose 0. My first term is 2y, so that's going to be raised to the 4th power. And my second term is negative 3. Make sure you keep that sign in there. And so negative 3 is going to start at the 0 power. And then it becomes plus 4, choose 1. 2y goes down by a power, so 2y to the 3rd power. Negative 3 goes up by a power, so negative 3 to the 1st. And then 4 choose 2 times 2y squared times negative 3 squared, plus 4 choose 3, 2y to the 1st times negative 3 to the 3rd, plus 4 choose 4, 2y to the 0 power, negative 3 to the 4th power. So a couple patterns to notice. Again, your n always stays whatever your original power was, and then your r starts at 0 and goes up to n. Your power of the first term starts at n and goes down to 0. The power of the second term starts at 0 and goes up to n. The power of the second term is always the same as whatever you're choosing, so 0, 0, 1, 1, 2, 2, so on and so forth. And the two powers added together always add up to whatever n is. So 4 plus 0 is 4, 3 plus 1 is 4, so on and so forth. So now I'm just going to simplify this, multiply everything out, calculate 4, choose 0, and try and simplify this. So on this one, I've calculated every term. 4 choose 0 is 1, 2y to the 4th is 16y to the 4th, negative 3 to the 0 is 1, and then so on and so forth for every single term. And now I'm just going to multiply everything out and simplify. So 4 choose 0 times 2y to the 4th times negative 3 to the 0 would be 1 times 16y to the 4th times 1, which is just 16y to the 4th. 4 choose 1 times 2y cubed times negative 3 to the 1st would be 4 times 8y cubed times negative 3, which is negative 96y cubed. 4 choose 2 times 2y quantity squared times negative 3 quantity squared is 6 times 4y squared times 9, which is 216y squared. 4 choose 3 times 2y to the 1st times negative 3 cubed is 4 times 2y times negative 27, which is negative 216y. And 4 choose 4 times 2y to the 0 times negative 3 to the 4th is 1 times 81, which is plus 81. So this is the expansion of 2y minus 3 to the 4th power. You can also use the binomial theorem to just find specific terms. So for instance, we want to find the coefficient of the term with y to the 8th power of the expansion 2y plus 3 to the 10th power. So we would set up our binomial theorem knowing that we want a y to the 8th. So I set up 10 choose something, I'm not sure what this is going to be yet, and then I know I want my y term to be raised to the 8th power, so I'm going to have 2y to the 8th power, and then 3 is going to have to be raised to a power that we're not quite sure yet. So this is going to use the rule that your two exponents have to add up to n. So if this is going to be an 8, then I need my other exponent to be a 2 in order for those to add up to n. And then this exponent is always the same as your r value. The second term's exponent, so the second term, which is 3, that one's always going to have the same exponent as whatever your r value is. So it's going to be 10 choose 2. So now we have our setup here. So go ahead and pause the video and find what the coefficient of this y term is. 10 choose 2 is 45. There's 45 ways to have 10 things and only choose 2 of them. 2y to the 8th power is 256y to the 8th power, and 3 squared is 9. So if I multiply all this together, I end up with the coefficient of the y to the 8th term is 103,680. So again, this is using the fact that your exponents have to add up to whatever your n value is, and the second term's exponent always matches your r value. The last way that they'll ask this question is it says find the 6th term in the expansion of x plus 2 to the 9th power. So we have to think about the term numbers when you're in standard form. So this first one here would be the first term, second term. So if you notice, whatever r is, it's 1 less than the term number. So if r is r, then the term number is really r plus 1. If this is n, there's really n plus 1 terms. So if we want the 6th term, we really want r to be 1 less than that. We want r to be 5. So using that, set up the binomial expansion to find the 6th term and actually find the 6th term of this expansion. So if we want the 6th term in this expansion, that means that we want r to be 5. So we're going to have n choose 5. And then I knew I was going to have x to some power and 2 to some power, because those are my two terms. So then I remember that whatever the second term is, that's going to have the same power as whatever r is. So 2 is going to be raised to the 5th power. And then I know that my two exponents always have to add up to be whatever n is. So in this case, they have to add up to be 9. So if this is 5, then the first term has to have an exponent of 4. So my expansion is going to be 9 choose 5, x to the 4th power times 2 to the 5th power. So 9 choose 5 is 126, x to the 4th is just x to the 4th, and 2 to the 5th is 32. So we end up with the 6th term in the expansion is 4032 x to the 4th. So this has been the binomial theorem. It's a way to expand binomials without having to follow them out all the way.